Again, good morning to all. So we'll start today by solving this example number 8 on the text. We have an emitter bias configuration for our BJT amplifier. So let's try to solve the usual parameters that are important, transistor currents and voltage VCE. So dito lang sila ko magsulat. So for IB, IC, IE, and VCE. Yung mga the usual parameters. Solve unless stated otherwise. So first we'll solve for IB. KBL to dire. Supposedly, mag-KBL to dire. Okay? So solve for IB. To solve for VCE, KBL po to dire. But again, we'll conveniently refer to our table para masimplify ang atong solution. Or at least atong process. So emitter bias man to. We'll refer to this set of formulas na dire. Okay. Solve for IB. Use this one. So solve for IC and IE kani sila, of course. And solve for VCE, this one. I don't know sa purpose animal, mas na siya purpose. So IB, VCE. So nanagita nan sa atong table. I've already uploaded the file for this PDF sa eLearn. So try to download it. So IB, IC, IE, and VCE wala na to invoke. So for IB is equal to VCC minus VBE all over RB plus beta plus 1 RE. Fill in the given. So 20 minus 0.7 all over 270K plus beta is 125, so 126 times RE of 2.2K. So nanalagid tanan given. We'd obtain an IB of 35.27 microamperes. Next, ICIE. ICIE na dayan. IC is equal to beta IB. So 125 times 35.27 micro. IC is equal to 4.41 amperes. IE is almost the same. Kung butang to direct IE approximately 4.41 milli, pwede na gyapon. But let's try to obtain the more accurate na numerical value. IE is beta plus 1 IB, so 126 35.27 micro. IE is 4.44 maybe, no? 4.40 11 4.44 4.45 35 naman, no? So plus 3 5. Yeah, nasa mga 4.44 siguro. Easy. VCE. VCE is equal to VCC minus IC quantity RC plus RE. VCC plus minus IC RE plus RC. 20 minus 4.41 milli. 470 is 0.47 K man na siya. Kilo ohms lang ako para uniform. Plus 2.2. VCE is equal to more or less nasa mga 8.23 volts. Final answer. All right. So far, to those who are present right now, any questions? Is it understandable?
Sir.
Something, yeah. Okay. Thank you. So, patulogid class, it's as easy as determining what kind of configuration is given and looking at the table for the pertinent formulas I use. Okay. So before ta mag-solve og more challenging examples for the emitter bias, let's proceed lang daw to voltage divider like this one. Say this is given. Kani, na siyang given. So same gyapon, no? Voltage divider. So it's either we'll use these formulas or these formulas. Ito try nga itong approximate. So will this be satisfied? Di man ta diretso mo gamit og approximate analysis unless masatisfy ni nga condition. Is beta RE greater than or equal to 10 times R2? Let's find out. So is beta RE greater than or equal to 10 times R2? What's beta? 80. RE is 0.68. 10 times R2 is 9.1 K. The answer. 54.4 K. Is 91 K. Pwede. No? So for this problem, we could not use the approximate analysis. Okay, wala man na satisfy. So the choice, have the exact approach. So solve for RTH and solve for ETH. Okay, given naman gitanad, no? So RTH is equal to R1 parallel R2. Yan na lang, no? So 62K of 9.1K. 1 over 1 over 62K. It's 1 over 9.1K. RTH is equal to 7.94. About ETH? ETH is voltage divider. VCC R2 over R1 plus R2. 16, 9.1 over 62 plus 9.1. 2.05. After mo obtain si RTH o ETH, if di ito mag-refer sa table, it's as if atong ibalik sa emitter bias nga analysis. So again, naman tayo table. Convenient pa tayo. Solving for IB. IB is instead nga BCC, ETH minus BBE over RB plus beta plus 1 RE. Yeah, beta plus 1 RE. 0.05 minus 0.7 all over. No, sorry, di na siya RB, RTH siya. So RTH is 7.94 plus 81 times 0.68. Okay. 94K man siya ba? Therefore, IB is equal to 21.42 microamperes. Space. Out of this, solve naman natin dito si IC. IE. 80, which is beta. 80 times 21.42 micro and 81 times 21.42 micro kappa. So IC is equal to 1.71 milliamperes. IE is 11. 42. 44. So, I'm sorry. 72. 1.73. Yes. IC and IE. For VCE, it's not only the same, I think, ang formula sa voltage divider o sa emitter bias. So VCC minus IC RC plus RE. VC is equal to VCC 16 minus itong IC na to. So 1.71 times 3.9 plus 0.68. 3.9. Sa mga 8.17 volts. Okay. Final answer. So, yun na ba? No? It's very procedural. Of course, as long as ang required is IC, IE, and IB, and VCE, dali lang magid ni. So, katuda, let's try to solve this one. Challenging na ni slide because lahi ang given, no? Problem number 10. This one. So this might be what we call a design problem because ang i-obtain nato is mga resistor values, no? Given as actually given si IE, diba? Given si IE. Indirectly given ang VCE. Diba? So ang wala is RC, RE, RB agad, no? Ning VB dali na siya. Okay. So before I proceed, class, word of caution lang. So si 7.6 is si VC, right? VC na siya. VC. Ang 2.4 volts, mga tinatawag nga VE. Meaning voltage measured from collector to ground. Ang VE, voltage measured from emitter to ground. Of course, si VB dire, measured from the base of the transistor to ground. Pilay voltage dala mo na siyang VB. Now, VC class is of course not equal to VRC. So dili siya directly na okay, VC is 7.6, IE is 2.2 milliamperes. So homologar na siya si RC. So it's not like that because again, VC is not equal to VRC. VC is not equal to the voltage measured across the resistor RC. So this is parehas. Now how about VE? State lang gyapon nato that it's not necessary that VE is equal to VRE. Dili gyapon. Yet in this particular case, pareha sila. Why? If mag-measure ta dire, measure ta gamit ta og multimeter, measure ta from across RE, ang makuha nato nga voltage actually is 2.4. Ano man, directly connected man pud to ground si RE, no? So in this case lang, V is RE. But state lang nato daan nga it's not necessarily so. Hindi na sa dapat i-think nato nga dili sila equal. Why? What if duha ka buok resistor dire? So duha natay RE1 ug RE2. So dili gid parehas si VE ug si voltage across each resistor. Okay lang kung connected directly to ground ang isa ka RE nga resistor. So VE is VRE. Pero it's not always the case. So state lang nato si ingana. We're fortunate enough for this problem that VE is equal to VRE. Of course, same kay VB, no? VB is not equal to voltage across RB. So, iba kung butang lang natin i-dire ng mga kuan caution. VB is not equal to VRB. Ang kaning naa sa left, muna siyang voltage na itong ma-obtain if we measure from the ground to each terminal. Whereas, kaning nga mga voltage is the voltage across the resistors. So, nag difference. May difference. Silong na lang. So, VC, of course, is not equal to VRC. VB is not equal to VRB. And VE is not always equal to VRE. But here, VE is equal to VRE, which is equal to 2.4 volts. So not always true na lang eh. Sometimes it's true, sometimes it's not. Okay, so I think you have some idea na on how to solve this one. Especially, we know that IC is already given. IC is 2 milliamperes. So once given ganing isa sa mga current class, actually masolve na itong all the other currents or the other two currents. Si IE, pwede lagi na siya approximately equal to 2 milliamperes. No? Okay, given man si beta, solve na ito yung exact. IE is beta plus 1. IB man din, no? So si IB ang muna ma-solve. So we know that IC is beta IB. Therefore, IB is IC over beta. So 2 milli over 80 would have as an IB of pila ba ni class? So mga 25 microamperes. About IE. So masolve na po si IE. IE is beta plus 1 IB. So 81 times 25 microamperes. So 2.025. Hindi sila mga itong objective. What objective is mga resistors. So si VCE actually, if mag-KVL ta dire, VCE is equal to VC, sorry, KVL equation lang sa VC minus VCE minus VE equals 0. So VC is 7.6 minus unknown minus 2.4, 0. Therefore, VCE is equal to 5.2 volts. Masolve na din si RE. Kaya naman tayo IE. No? So, RE Ohm's law. RE is equal to V times V over I. VE over IE. VE is 2.4 given. IE is atong obtain. Pila to? 2.025 milli. Therefore, RE is 1.185 more or less kilo ohms. And now 0.185. So kung ato si RE. Si RC, pwede na ito gamitin itong mga equation na gikan sa ating table class. To solve for IB, sorry, okay na, subject. Ano man to? IB is VCC minus VBE all over. So it's ito. Solve for IB. RB plus beta plus 1 RE. Okay, one equation, one unknown. One equation, unknown naman eh. Given man si IB. I mean, nakuha na si IB, 25 micro. So 25 microamperes is equal to VCC of 12 minus VB of 0.7 all over unknown RB plus, how much is beta? 80. So 81. How much is RE? Obtain na ito, bago lang yun, 1.185. Kilo. Yan na. Solve for RB. Nasa mga 350K. 356K. Last is CV, si RC. And we know mo si RC using the formula ni DCE. And lagyan mo sa table. No? So VCE is equal to VCC minus IC RC plus RE. Ito. Given naman ito nun. VCE is ito. 5.2. BCC of 12 minus IC of 2 milliamperes given 2 milli. RC is unknown. RE is 1.185K. So we could solve for RC. Two 2.2K, more or less, no? 2.215. 2.2K. Final answer. Okay. So for problem number 10, any questions? Now, even though different type of problem siya to what we normally solve, but again, so good sa kaninga parts analysis, I still use the formulas na nasa table. Dili lang is maybe na ay na-add lang gamay na steps, no? Pero steps na cover naman gyapon nato previously, right? KBL ug Ohm's law man gyapon eh. Ani, this is Ohm's law, this one. Kani KBL man eh. Kay the usual man nga formulas, IC, IE, IB. So kung ano kita na, no? Na-layout na ito tanan completely. Needed na tools and procedures. Okay. So if there are no more questions, I'll end the recording here.